In this video, I will briefly introduce data and information visualization. Let's first say a word about the difference between data and information. Usually when people say data, they mean something raw with very little structure, whereas information has more meaning and is more synthetic. In people's everyday language, the two words can sometimes be interchanged, but data usually means raw text and figures, and information is something more meaningful. Producing a visualization is about turning raw data into human, understandable information. As you can see in this example, raw data can have some level of formal structuring. Here it is a list of lines with headers and comma-separated values. This is a machine-readable structure, but most humans won't be able to see much in this bunch of figures. A visualization shows some meaning of the data. In the visualization, you can immediately see that the data is about 4 political parties. We can see relative importance, that is, the two dominant parties are Conservative in blue and Labour in orange. We also see the evolution over time. The Conservative Party was dominant in the 80s and brutally lost influence in the 90s, then later gained back seats at the parliament. In other words, a visualization helps analyze data, so it is not necessarily an end product that you produce for users. It can also be something you want to build for your own understanding and exploration of data. Building a visualization can be a way of analyzing data. Of course, a visualization can also be about presenting the data to others in a meaningful way. 4 main types of information can be identified: numbers, that are continuous variables, quantities, ordered values, proportions, and scatterplot, bar charts, pie charts, etc. are very popular to represent that kind of data. For textual data, what can be visualized are categories and relations. Besides mere sets or lists, there are 3 main formal structures: tables, hierarchies, and graphs, with several possible types of visualizations for each. When the data has a temporal dimension or involves flows, you will probably use specific types of visualizations, like timelines or Sankey charts. The same for geolocalized data with maps. This typology is just to give some landmarks. In reality, a lot of visualizations involve several of those types. There are numerous declinations and combinations of these visualizations, as well as many other forms. You can check these 2 websites that have very good catalogs of visualizations. The documentation of JavaScript, Python, and other programming languages that have a visualization library are also a good source for inspiration. The graphic and visual vocabulary has 4 main items: spatialization, color, size, and icon or symbols. Here is an example that shows how spatialization is important for reader to recognize categories. And recognizing categories is essential both for analyzing and understanding data. Here you can see how color can make some elements stand out, which means you can use color to help readers see categories or relations for elements that are not spatially connected. Spatialization has 2 or 3 dimensions. Color provides additional dimensions. In most kinds of charts, the size of elements is very meaningful. Size represents quantities, importance, including relative proportions and relative importance. Simple geometric shapes bring additional representation for series and categories, but icons and other images can also add a lot of meaning to a visualization. To this baseline vocabulary that has been used at least since geographical maps were drawn, digital tools have added new features, animations, and interactions. This has 2 main benefits: more possibility to show an evolution over time, and by interacting with the visualization, the reader can adjust the size of the token of information she can swallow, getting a general idea first and then looking more into details she's interested in. Let's wrap up with a warning about visualization. The lack of properly represented context can lead to misinterpretation. A chart like this one can make you think young people were overwhelmingly against Brexit. But if abstention is also shown, the interpretation is different. Also, an advantage of visualization is to help people remember information. If you build a stunning but oversimplified visualization, you will make people remember something wrong. So you need to make sure you do not sacrifice the world's complexity for a stunning but misleading visualization. This is it for this brief introduction to data and information visualization, and here is the link to the presented document.